Trigonometric functions. We all love them, right? Trigonometric functions are all about the characteristics of triangles and, all that fun stuff. Either way, if you are in the vast majority of students at EARJ and you just love this unit so much that you forget everything about it right before the finals, I am here for you. In this video, we're going over all you need to know about the trigonometry unit. Here's some quick timestamps so you can skip ahead to whatever you'd like to learn. Ready? Here we go. So, that's enough about triangles. Let's look at some circles. This is what we call the unit circle. Why is it called the unit circle? Well, because its radius is just 1 unit. That means wherever I draw this line, as long as it stems from the center of the circle and ends at its circumference, the length of the line will be exactly 1. Always just 1. Then, knowing that the radius of the circle is exactly 1 unit, what are then the coordinates of this point right here? Exactly 1, comma 0. What about this point? 0, comma 1. And this point? Negative 1, comma 0. What about this one? 0, comma negative 1. But wait, isn't trigonometry all about triangles? Why are we looking at circles? Well, let me show you where the triangles come in. Here we have a line representing the radius of the circle. Now let's draw another line which is going to be perpendicular to the x-axis. Oh, look at that, we have a right triangle. You know what that means? Sine, cosine, and tangent are back yet again. That is, if we consider the angle here, let's name it theta, we can in fact deduce its sine, cosine, and tangent. Again, how do we find the sine of theta? The opposite over the hypotenuse. And how do we find the cosine of theta? The adjacent over the hypotenuse. But look at this. We can actually simplify it much further. Because we know that hypotenuse is exactly 1 unit, we can simplify these terms. That means the sine of any possible angle within this unit circle is just going to end up being its y-coordinate. Similarly, the cosine of any possible angle within this unit circle is just going to end up being its x-coordinate. So for any possible angle theta, the x-coordinate is just its cosine, and its y-coordinate is just its sine. This you'll just have to remember. Speaking of remembering stuff, let's talk more about these angles. On the coordinates we've just drawn, we can express these angles differently. For instance, let's say we're starting at the first point, 1, 0. Let that be 0 degrees. Then let's move to the next point in a counterclockwise motion. Here we made a 90-degree angle. Next, we've made a full 180-degree angle, then 270-degree angle, and finally we're back at 0, made a full 360-degree angle. But wait, you shouldn't still be using degrees to express angles, because here in trigonometry we actually use something called radians. To turn degrees into radians, just multiply any number, any angle, by pi over 180. Let's try. 90 multiplied by pi over 180 is just going to give us pi over 2. And just remember that these mean the exact same thing, but radius is just a simpler way to calculate angles. Next, let's try the 180-degree angle. 180 times pi over 180 is just going to give us just pi. Next, 270 multiplied by pi over 180 gives us 3 pi over 2. And finally, 360 multiplied by pi over 180 gives us 2 pi. Now, we've translated every angle here to radians. And what you should do is to make the full unit circle, which looks like this, just do the same thing with the 30, 45, and 60-degree angles. Once you've done this, you're going to have the full unit circle. And this, I'm sorry, but you'll just have to memorize it. Now that we've greeted our beloved circles, any rational student at EARJ would ask, but how does the function function? Let me tell you how it functions. It's actually very simple. Here we have a function, and here we have the formula for a trigonometric function. You'll get this on your exam. Let me walk you through what this mysterious language means. Firstly, the k at the end means the midline. It is the average of the maximum and minimum. This is how you find the averages, obviously. Here's the midline of this graph in particular, -1. Then the a stands for the amplitude. It's the distance between the top and the midline. Or you can just use this little cheat code to find it more easily. Here's what we get if we use it. 3. Then to find b, you have to divide 2 pi by the period. What's the period, you ask? It's the distance between the two maximums or two minimums. We're literally given this in the graph itself, so finding b is easy here. One maximum is at 7 pi over 12. The other maximum is at 19 pi over 12. Find the distance between these two. Now divide 2 pi by the answer. Finally, put in some points on x and y to find c. Let's just use our first point, 7 pi over 12, 2. Now you can just solve this to find the answer for p. We're going to look at some examples how to fully solve this later on. Okay, so by now we all understand the theory. Now, how do you put this into practice to get some good grades? Let me walk you through some of the formative and summative questions, which will be quite easy now that we fully grasp the unit circle and how to express angles in radians. This one is easy. It asks us, the sine of an angle theta is 2 squared over 2. What could this angle be? Easy. Just refer back to the unit circle. It's asking us to find an angle whose sine is 2, the square root of 2 over 2. Since we already know that this sine refers to the y-coordinate, just search up the points on the circle whose y-coordinate is the square root of 2 over 2. Can you find them? Yep, there they are. 2 pi over 2 is the sine of these 2 points. Pi over 4 and 3 pi over 4. Easy, right? Just find out where the statement is true. So just find out where the sine of an angle equals pi, the square root of 2 over 2. Okay, here's another easy one, almost the same thing. Always remember to think of angle theta as a variable x. And remember, we always want to isolate the variable on one side of the equation by itself. Let's move everything to the other side then. Plus 1 on both sides. Then divide both sides by the square root of 2. We can rewrite this while keeping the square root in the numerator, as you always should. Now Mr. Corey is basically asking us, find me an angle whose cosine is the square root of 2 over 2. Easy. Look at the unit circle. Where is the cosine of angle, the square root of 2 over 2? At pi over 4 and 7 pi over 4. But, oh look, suddenly there's a different domain. Remember how a circle is 360 degrees, or 2 pi? Well, now it's asking us to find it within 4 pi, which means another rotation. So let's just add another 2 pi to our answers. Remember how to add fractions? Pi over 4 plus 8 pi over 4 gives us 9 pi over 4. Furthermore, 7 pi over 4 plus 8 pi over 4 gives us 15 pi over 4. So now we have our 4 answers. Remember, always check your domains to see how many times you have to add 2 pi to your answers. This just tells you how many rotations you have to make around this unit circle. Here it says 4 pi, right? So we're going to make 2 rotations to each angle. So therefore just add 2 pi once. Finally, let's get to the most annoying part. Word problems. We'll do one that a lot of people struggle with, even though it's actually really simple. Here's our word problem. Pause the video so you can read it. Done? Alright, let's go. So, to not get confused, let's divide everything into step by step. What's the first thing you should do with this formula? Easy, just define the variables. We're given 2 variables here. H of t, which is the dependent variable, and t, which is the independent variable. Let's say h of t is height in meters, and t is time in seconds. What's the second thing you should do? Remember? That's right. Find the midline and the amplitude. Those are the easiest ones to find. So to make this easier, let's draw the Ferris wheel differently. The word problem says that the Ferris wheel is 2 meters off the ground. Then it has a radius of 15 meters to the middle, and another radius of 15 to the top. Now it should be obvious what the midline is. The midline is, of course, the very middle of the rotation. That's here at 17 meters. And then the amplitude is how far up or down you need to go to reach the maximum or minimum. That's 15. Next, what's the third thing you should find? Yep, the constant b. Remember, to find the constant b, you need to divide 2 pi by the period. The period is always given in the word problem itself. The period is just how long it takes to end up back where you started. That's 60 seconds for one rotation. Let's plug it in. 2 pi over 60 gives us pi over 30. That's b. Now, we only need to find one more value. That's the constant c. How do we find c? Well, we plug in some values for time and one for height and find out that way. Here we know that after 0 seconds, for example, a chair will be at the very bottom, or 2 meters off the ground. So we can replace t with 0 seconds and h of t with 2 meters. Now let's solve it. Move everything to the other side until only c remains here. Minus 17 both sides. Great! Now divide both sides by 15. Great! Now to get rid of the sine, look at the unit circle and find an angle whose sine is -1. just like we practiced. Great. 3 pi over 2. Next, divide both sides by pi over 30. Remember the keep, change, flip method for dividing fractions. Now, what we find is that 45 equals 0 minus c, which means 45 equals negative c, which means negative 45 equals c. And we did it! We found the function. Good job! You are now a professional trigonometry person. I'm proud of you. Good luck and goodbye.